Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to determine the K value, the equilibrium constant for the following species in water, and that's going to be pyridinium chloride, or aka also known as pyridine hydrochloride. So let's get into this. Okay, so the first thing we need to understand is what exactly is pyridinium chloride, or aka pyridine hydrochloride. Well, basically, you're taking the pyridine, which is a base, and you're reacting it in a hydrochloric acid solution. And so we know that hydrochloric acid is a strong base. Oh, I'm sorry, strong acid. What am I talking about? So it's a strong acid. And so if you write the formula for pyridine, I have it here. Yes, C6. So So C5H5, and then you have your N, and here it's going to be the formula pyridine, and you're going to react that pretty much it. You're going to put that, mix it with a strong acid, HCl, hydrochloric acid, and because hydrochloric acid is a strong acid, and this is a weak base, then basically all of your base here is going to be converted into the conjugate acid for the pyridinium. So here it's going to go and become C5H5 and then NH plus, and then you've got the chloride ion left behind, and so you've now got this these charges here. So you have your positive ion and your negative ion. Oops, let me fix this a little bit. And so when you have this as a solid, if you were to evaporate this, it would form a solid, and these are going to come back together, and you're going to get a salt, and that salt is called pyridinium chloride, or pyridine hydrochloride. And so basically, when you then ask the question, determine the K for the following species in water, you put this in water, it's going to, of course, dissolve into these ions. And the chloride ion is the conjugate base of a strong acid, so this is going to be neutral in water. It's not going to have any effect in the water. So the main species we're going to be looking at is this right here. So we want to find the K value for this. Since this is a conjugate acid of a weak base, it's going to be the Ka. So we need to start with the base. And also the formula that's going to be really important for us is going to be Kw is equal to the Ka of the acid multiplied by the Kb of the conjugate base. So this is related to Kw by the conjugate acid-base pair. So this has to be the conjugate acid-base pair that we're talking about. It can't be just any acid or base. It's got to be the conjugate acid, conjugate base pair related to each other. If you take the K values for the conjugate acid and conjugate base pair, that's going to equal Kw. And so Kw, as we should all know, is 1.0 times 10 to the negative 14. So since this is a weak acid of a conjugate base, we're not going to be able to look this up, but we do know the Kb of that. So this we can look up, and when we look up the Kb, it's 1.5 times 10 to the negative, 9. Yes, to the negative 9. Okay, so we looked up the Kb value, and so now all we need to do is plug in this with the Kw. So Kw, again, Ka, we're looking for Ka, the K for this conjugate acid here. That's going to be equal to, that's going to be multiplied by the Kb value 1.5 times 10 to the negative 9. That's going to be equal to 1.0 times 10 to the negative 14. So now all we need to do is divide 1.5 times 10 to the negative 9 on this side. 1.5 times 10 to the negative 9 on this side. So this cancels out, and we get Ka is equal to these two divided together. And so we get 6.67. 6.67 times 10 to the negative 6, I believe. Yes, to the negative 6. So here we have the K value, or the Ka value, for the pyridine hydrochloride, or also known as pyridinium chloride. So I hope this was helpful. If you enjoyed the video, if this helped you out a lot, then by all means, please, by all means, like the video, share the video, hit that like button. Also, subscribe to my channel. That's all I'm asking. Subscribe to the channel. Hit that notification bell up there. And then when you do that, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.